Hello, I'm Stephen Dang Ma. I am a third-year GIS student at Texas A&M University in College Station, Texas. My team is led by project leader and PhD candidate Parveen Chetri and department head and professor David Cairns. Other members include Eric Martinez Luna, he's our team leader, Leslie Galvin, Krishna Hingraja, Blake Wellborn, and myself. We are researching the forest line distribution pattern and controlling factors in the Nepal Himalayas. To briefly introduce the subject, forest lines are very important to environmental analysis. Knowing the conditions of a forest line can give answers to many questions about climate change, pollution, and biodiversity. Many studies have documented altitudinal expansion of forest line in mountain ranges of the world. Accurate confirmation of forest line advancement are still insufficient and are not clear, which might be due to lack of georeference forest lines. Use of remote sensing and GIS can account the georeferencing issues and can help in analysis of forest line distribution patterns and controlling factors. Orographic, edaphic, anthropogenic, and climate settings affect forest line limit and distribution. The first objective of this project is to map the forest line distribution patterns. We need to have data to analyze. The second objective is to determine how aspect and slope affect forest line. Aspect is the compass direction that a mountain is facing. This is important because it determines how much sunlight the vegetation on that particular mountain gets and can be a factor of forest lines. Slope can affect forest lines because trees need to be able to grow without being derooted and falling over. Slope can also affect how a tree can disperse its seeds as well. The third objective is to determine other factors controlling forest lines, like human settlement and climate change. In this portion of the experiment, we are at the Dorpitan Hunting Reserve in central Nepal. While this is only one area of study, a few members will be traveling to Nepal to other reserves to collect more data in the summer of 2016. Here we mapped the outline of the hunting reserve in cyan. This is a zoomed-in satellite image of the Dorpitan Hunting Reserve. We used ArcGIS to zoom into the image and drew red lines to represent the forest line. This is the digital elevation model of the Dorpitan Hunting Reserve. The mountains stand very tall, only about 1,000 meters less than Mount Everest. The area ranges from 1,289 meters to 7,633 meters in elevation. With changing elevation, there is temperature change. Trees can only grow when temperatures are suitable. Using this digital elevation model, we can analyze forest lines in comparison with elevation and temperature. Using remote sensing, we converted the satellite image to determine the slope of the mountains. The green represents flatter areas, whereas the red represents area of greatest change in elevation. Lastly, we used remote sensing again to convert the satellite image to determine aspect. The red represents north, the yellow represents east, light blue represents south, and dark blue represents west. The ordinal directions are represented by the mixtures of the colors that represent the cardinal directions. In this table, we determined the maximums and minimums, basically the lower and upper limits of the forest lines of each aspect. We also computed the mean and standard deviation, as well as the average slope. We graphed the upper limit of the slopes of each aspect and compared it to the average elevation by the slope of Nepal. We found that the Dorpitan Hunting Reserve, specifically the southwest aspect, where the aspect was less than of Nepal, was largely impacted by human sediments and topography. In conclusion, we found that the forest line ranges from 3,100 meters to 4,060 meters in the Dorpitan Hunting Reserve. Slope exposure analysis indicates presence of human disturbance in the south-facing slope. Lastly, human disturbances and topography are the major factors controlling forest line distribution in the Dorpitan Hunting Reserve. Thank you. Have a great day.